When we think of Mercury, the closest planet to the Sun, we imagine a scorched, lifeless world, a barren rock bombarded by solar radiation with searing temperatures during the day and bone-chilling cold at night. Hardly a place one would expect to find anything remotely resembling life. But recent discoveries have turned that assumption on its head. Scientists have just revealed that Mercury may host ancient salty glaciers beneath its surface, and this unexpected revelation has scientists wondering, could the planet closest to the Sun actually harbor some form of life? Welcome back to Space Lab, where we journey into the deepest mysteries of the cosmos. In today's video, we're diving into one of the most surprising planetary discoveries in recent memory, one that could potentially rewrite what we know about habitability in our solar system. Let's start with the basics. Mercury is the smallest planet in our solar system and the one nearest to the Sun. It completes an orbit in just 88 Earth days and has virtually no atmosphere to protect it. That means surface temperatures can soar to nearly 430 degrees Celsius (800 degrees Fahrenheit) during the day and plummet to -180 degrees Celsius (290 degrees Fahrenheit) at night. With such brutal conditions, Mercury has long been considered one of the least likely places to find anything of interest in the search for extraterrestrial life. But despite its harsh environment, Mercury has been full of surprises. In 2012, NASA's Messenger mission shocked scientists by confirming the presence of water ice in permanently shadowed craters near Mercury's poles. These deep craters, never touched by sunlight, act like natural freezers, preserving water ice for potentially millions or even billions of years. That discovery was enough to make scientists take a second look at Mercury's geology, and that second look has just paid off in a big way. The latest breakthrough comes from a team of planetary scientists who reanalyzed MESSENGER data and combined it with thermal models and spectroscopic analysis. What they found was shocking: large patches of Mercury's surface, especially near the poles, exhibit characteristics consistent with glacial structures. But here's the twist: these aren't just any glaciers. They're salty. These glacial formations appear to be ancient deposits of water ice mixed with salts, possibly magnesium sulfate or sodium chloride, essentially the same kind of salt we find on Earth. The presence of salt is crucial. Not only does salt lower the freezing point of water, allowing ice to remain stable in warmer temperatures, but it also plays a major role in the chemistry of life. Salty environments on Earth, like underground saltwater lakes in Antarctica, have been shown to support microbial life in extreme conditions. One of the biggest questions is how these glaciers formed in the first place. There are a few theories. One possibility is that Mercury had more water in its past than we thought. In its early history, the planet may have had volcanic activity that released water vapor and other volatiles into space. Some of that water could have migrated to the poles and become trapped in craters. Another possibility is that water and salts were delivered to Mercury by comets and asteroids over billions of years. These celestial bodies are rich in both ice and organic materials. As they impacted Mercury, they could have deposited icy and salty material in the polar regions. Over time, this material may have been compacted into glacial-like structures, preserved in the planet's cold traps. Either way, the presence of salt suggests more than just a geological curiosity. It opens the door to chemistry, and where there's chemistry, the possibility of life isn't far behind. Let's be clear, no one is saying there are aliens hiding out on Mercury. The surface is far too hostile for complex life as we know it. However, the subsurface may be a different story. Salt not only helps preserve water but also shields against radiation and can provide a stable environment for microbial life. If there are pockets of briny water beneath the surface, perhaps warmed by residual heat from the planet's interior, it's possible that microbial organisms could survive there. This isn't unprecedented. On Earth, extremophiles, organisms that thrive in extreme environments, have been found in places once thought utterly uninhabitable, in deep-sea hydrothermal vents, under Antarctic ice, and even in salt-crusted deserts. Some of the most extreme examples come from hypersaline environments, where bacteria and archaea have evolved to flourish in salty brines. The discovery on Mercury hints that similar habitats could exist there. And even if there's no life now, Mercury might preserve evidence of ancient microbial activity. Fossilized biosignatures, chemical traces of biological processes, or even preserved microbes in frozen brine pockets could lie hidden beneath the surface. NASA and the European Space Agency are already ahead of the curve. The BepiColombo mission, a joint effort between ESA and JAXA, is currently en route to Mercury and scheduled to enter orbit around the planet in 2025. One of its goals is to study Mercury's surface composition in greater detail than ever before. With advanced spectrometers and high-resolution cameras, BepiColombo could directly confirm the presence of these salty glaciers, and perhaps even detect signs of organic molecules or other biosignatures. If BepiColombo finds evidence supporting this salty glacier theory, Mercury may suddenly jump from dead rock to priority target in the hunt for life. It would also raise profound questions about how many other seemingly lifeless worlds in our solar system, and beyond, might actually harbor the ingredients for life in hidden, unexpected places. This discovery forces scientists to reconsider the traditional, habitable zone, concept, the idea that a planet must orbit at the right distance from its star to support liquid water on its surface. Mercury is far outside that zone, yet it may still contain ice and the chemistry necessary for life, thanks to its unique polar conditions. If Mercury can host icy, salty glaciers with the potential for life, what about other unlikely worlds? The Moon has permanently shadowed craters with water ice. Mars has subsurface brines. Even asteroids and dwarf planets like Ceres show signs of buried ice and salt. The more we look, the more we realize that life might not need a temperate paradise. It might just need a stable pocket of water, some minerals, and enough time. The discovery of salty glaciers on Mercury is a stunning reminder that the universe loves to surprise us. What we once thought was a barren wasteland may actually be a vault of secrets, perhaps even biological ones. As the BepiColombo mission prepares for its arrival, scientists are sharpening their instruments, ready to peer beneath the surface of Mercury with fresh eyes. And as they do, we're left with one haunting question: what else are we missing in the places we thought were empty? Thanks for watching. If you enjoyed this deep dive into Mercury's hidden glaciers and their implications for life beyond Earth, don't forget to like, subscribe, and ring the bell for more cosmic discoveries from Space Lab. And drop a comment below: do you think Mercury might hide microbial life, or is this just another strange but sterile world? Scientists have just uncovered something astonishing beneath Mercury's surface, something that could rewrite the story of our solar system and expand our understanding of where life might exist. It turns out that Mercury may host ancient salty glaciers, locked in shadowed craters and possibly hiding more than just frozen water. These glaciers are chemically rich, and surprisingly, they might hint at habitable conditions deep beneath Mercury's crust. In planetary science, salt is also important for another reason: it lowers the freezing point of water. This means that in an environment like Mercury's poles, where temperatures hover just below freezing in some shadowed craters, water mixed with salt could remain semi-liquid, forming briny slushes or underground lakes. These could exist today or may have existed in the recent past. Thanks for watching Space Lab, where the universe comes to life.